if you go back 500 years ago, 1000 years ago to 2000 years ago, astronomy was not what astronomy we call today. So basically, astronomy was practiced for making proper ritual systems, for predicting the ritual timings, for predicting or understanding calendars, when tides will come, when this, the natural phenomena will occur, all these systems. So to live a comfortable life, astronomy was practiced. But properly speaking, if we think about the present day modern astronomy, means we are looking at the sky and working and thinking and actually researching, trying to know about the physics and chemistry of the sky related objects, celestial objects like stars, galaxies, and etc. The planets, sun, and moon. So, this particular type of astronomy means if we want to know how nature works, astronomy is the best laboratory for that. So, likewise, if we think astronomy, that practice gradually came bit later. We have to go to those ancient Indian places or those ancient India thousands of years ago, and we will see a series of names like this. They were all great astronomers: Lagod, Aryabhatta, Brahmagupta, Varamir, Bhaskara, Lalla. Bhaskara was, there were two Bhaskara. Most of them were excellent mathematicians. They were astronomers, and they were all Siddhantic astronomers who used to compile texts, who used to write texts to basically predict how we should live a comfortable life, understanding how nature works. However, if we think about modern day astronomy, that kind of astronomy most probably was fantastically practiced by this great person in Indian soil, Aryabhatta. So he was the person who most probably was the first documented person in India or in Indian subcontinent soil who not only practiced astronomy for the sake of gaining or dealing with a modern or comfortable life. Means when I should do a ritual to so that our family remains well, when I should do agriculture of a particular type of crop. Not only that, so he was the person who used to practice the real kind of astronomy what we know today. Means to know how nature works, what nature wants to tell us. He was the first person who explained in the world. He was the first person who explained what is a lunar eclipse and what is a solar eclipse. So why those things happen. He was the first person who in the world who actually gave us the notion how daily rotation of the sky is happening, and that is happening due to the rotation of the earth. So why I am telling this? Because one of his book till now exists, Aryabhatyam. By reading through those books, people, the specialists who were experts in decoding the ancient code texts, they were able to come up with these things, that he was even the first person who was able to calculate the length of a day almost very precise to the second decimal place of the seconds. So this was a great achievement if we look into the time when he did it. He was a person who lived in Indian soil during the time of around 500 AD or 500 CE, around 1500 years ago. And as time was progressing, the best place where India's modern day astronomy started flourishing was Kerala. If you go and start reading about history of Indian astronomy in a bit more details, you will see that during this time, 7th century to 12th century, a excellent school of astronomy was established in Kerala, and so many great astronomers, even Siddhantic astronomers, mathematicians, all emerged from this Kerala school of astronomy. One of the greatest scholars of this particular school was Nilakanta Somyaji, who in 1500 wrote a book, and in that book he actually calculated using simple trigonometry. He actually calculated that planets are revolving around sun in an elliptical orbit. So it was even around 43 years before Copernicus gave his idea that planets are revolving around sun. And 109 years before, Kepler provided this idea that planets are revolving or planets are moving in elliptical orbits. So that book also, Tantra Sangraho, it also still now exists. So these were some of the great achievements from Indian soil during those days. But if we talk about modern astronomical research, studies of modern astronomy, we had to wait. Indian soil had to wait for a long time so that modern Indian astronomy research will start. So, this is how astronomy was going on. And during all those days, as time was progressing, you might be happy to know that there were some here and there, some people, some kings, some queens, they were also practicing astronomy. They were interested in astronomy, so they were practicing astronomy. So, one of that great king of India was from Jaipur region, Rajasthan, Swai Jai Singh II, and in 1730s, 1720s, and 30s, he made 5 observatories. These 5 observatories were known as Jantar Mantar. The best Jaipur. I would definitely suggest all of you, please go there once you visit the Jantar Mantar of Jaipur and see how those days these huge machinery instruments used to work. There are 12 such machinery huge instruments made by Jai Singh, Samrat Jai Singh, and he was extremely interested in practicing astronomy, precise astronomy. All these wonderful instruments still now work very precisely, and among them you see this particular instrument which is known as the Samrat Jantra. The Samrat Jantra is the world's largest working sundial, and it till now gives you time every 2 seconds. It has a precision of every 2 seconds. You see, sunlight is falling, and as sunlight is falling, you can go here and you can measure what is the time. So every 2 seconds, the time will change. So this is the largest man-made sundial in the world, which is still now working. So any astronomy enthusiast, anyone who loves astronomy, who loves to study about Indian astronomy, I would definitely recommend, please go and visit Jaipur. Please go once to this wonderful, excellent place to get an idea about ancient day Indian astronomy. It is a beauty, it is a marvel. Different people, excellent number of visitors from across the world every day comes and visits this place. This is highly well preserved. All the instruments are well working, and there are wonderful guides from Archaeological Survey of India who will explain each and every instrument how they are working. They are till now precisely working. So please do visit it. And this is how astronomy was going on in India during before 18th century, before 19th century, before the British came. When the British came, gradually the modern astronomy system, the modern astronomy research started coming to India. That is a long history. I will not go to the very details of that. But yes, what was world doing when India was doing these machinery things? When I am talking about 1700s, before that, during
Wait, wait.
1600s, yeah, during 1600s, 1609, 1610, 1608, these were the times when the best possible astronomical instrument through which we can probe the outer space was already invented, and that was the telescope. My friends, you have to understand, you have to know. If you don't know, then from today onwards, you have to remember that it was not Galileo who discovered the telescope, who invented the telescope. He was not the inventor of the telescope, but he was the first person who used a telescope to look at the space, to look at the sky. So this is why Galileo was important. In 1609, using this particular telescope, he looked at the sky for the first time, because he knew he was an excellent, wonderful genius. And in 1608, when telescope was invented, this news spread rapidly to the European countries gradually. Galileo also knew about an instrument through which you can look at very far away objects, and far away objects will become magnified. That they will appear larger. So he was a genius. He readily understood that, okay, if we can use an instrument to look at faraway objects and those faraway objects will become bigger, then what is the best use of that kind of instruments? Look at the sky. So he made his own telescope and started looking at the sky. And that is why from that day onwards, 1609, when he first pointed his telescope towards the sky, that time is known as the birth of modern astronomy. Our understanding about the nature, our understanding about science and the sky, astronomy, everything changed from that date onwards. Without going into details how telescope works and all these things, you can go into other talks and go into internet or books to see. I would now come to where we are situated now. See, from though at that day, from the time of Galileo having those simple telescopes, we have come a long way. So this past 400 years, little more than 400 years, is the time when we have been able to observe and able to see the depths of the sky with the greatest instruments, the greatest technological advancements, and our understanding about science, our understanding about nature, physics, chemistry, our understanding and development about technology has changed completely. Presently, we have such giant, excellent instruments or telescopes in the space itself. You know about Hubble Space Telescope, we know about James Webb Space Telescope. These are excellent wonders of engineering, technology, and science. Without excellent advancement in engineering, technology, and science, these type of instruments wouldn't have been possible to make. So from that day, where our Galileo was having a very small telescope of the diameter of around 2 inch, means the diameter of this lens through which light passes in the tube of the telescope was only 2 inch, and now we have telescopes in space. And even if you go to Hubble Space Telescope, this Hubble Space Telescope size of the mirror is 2.4 meter. The size, it is the size of a football field, the whole telescope. And it is this particular telescope, James Webb Space Telescope, is much more advanced, excellent systems. Now we need to understand as technology gradually developed, as our understanding about science and technology and nature developed, people came to know that we have to develop telescopes in all different ways and all different techniques. What does it mean? So we were able to understand, people were able to understand that when we see something, when we see light, light can be of different types. So light, we know that it is a type of energy, and in the whole range, light can span in the whole electromagnetic spectrum in a whole huge range. So the light which our eyes can detect is only known as visible light or optical light, and that range is very, very small compared to the whole range of light. So if we see this electromagnetic spectrum, this picture shows you that from starting from the high energy X-ray, which is also a type of light, means the same electromagnetic energy, to X-ray, to gamma ray, to ultraviolet, to optical, going towards gradually going towards longer wavelengths, but lesser energy, infrared, radio, microwave, all these seven types of lights, they cannot enter our atmosphere. Our eyes are only sensible to that simple small window of light which is known as the visible light or visible window. But if we do not get light coming or the other types of radiations and energy, EM radiations, X-rays, ultraviolet, infrared, radio, if we cannot capture those radiations coming from space, if we only try to see the whole universe, the whole sky using the light which we can detect through our eyes, then it will be like that a blind people trying to understand what an elephant is. So gradually we have been able to provide, we have been able to make telescopes and instruments which will be sensible to detect all types of electromagnetic radiations. So there are telescopes which can detect X-rays, there are telescopes which can detect ultraviolet. For every type of radiation, we cannot put the telescopes in our ground because you see X-rays will be completely blocked by the ozone layers. So, and if there is oxygen in the atmosphere, that will absolutely block basically the X-rays and gamma rays. So likewise, we have to prepare, we had to prepare ourselves for multi-wavelength astronomy, multi-messenger astronomy. And why we need this? Just to give a very basic example, look at our sun. Using visible light, if we look at our sun will look like this. Very calm and quiet. We all know sun is a big ball of burning gas, very violent, but very active. But by looking at this visible light image, can anyone tell that it is a burning ball of gas? So basically, our own very own nearest star, sun, hides its real entity if we look at it only using visible light. The same way, if blind people are trying to understand what an elephant is. Now, the same sun, if you look at through infrared telescope, you understand that okay, sun is not calm and quiet. It is something. It is not a calm and quiet ball of something staying calm. Same sun, if you look using ultraviolet and then X-ray, then the sun will reveal its actual glory. We can understand that actually it's a very dangerous ball of fire, ball of burning gas by other lights, but by other types of telescopes, other types of visions. So if our sun, our nearest star, hides itself in one particular wavelength or one particular EM range, EM band, we have to explore our own sun using all the possible electromagnetic bands. Then think about the whole universe. And that is why astronomy has developed into a stage where it is one of the most powerful subjects and most powerful science, definitely one of the most powerful science subjects in the world now. We can explore the world, we can explore the outer sky, the universe in every possible electromagnetic waves. And our India presently is one of the leaders in astronomy and space science research. So for studying astronomy, for understanding astronomy in a deeper way, in a proper research oriented way, we have to take help of very big telescope systems like this. We are in our own India also have some of the finest observatories, institutions, research institutes and universities and space research centers through which we can study space, we can develop our own needs so that our future generation can get some benefits in every aspect. This system of telescopes is a radio telescope system. These telescopes will not look like traditional optical telescopes. You can understand that if you go to some place known as Narayangau, it's near Pune, around 90 kilometers away from Pune, you have this, you see, huge chain of 30 telescopes spread over a distance of an area of around 25 square kilometer. And there are 30 antennas like this. Each antenna is having a diameter of 45 meter, and each antenna is a radio telescope on its own, and this is known as the giant meter wave radio telescope system, the best, the most sensitive radio telescope system in the world in meter wave region. So you can use these telescopes, a single telescope or a single antenna can be used as a telescope, and using electronics, using super powerful electronics and computers, you can combine, virtually you can combine the signals coming from all the 30 antennas, and virtually you can make a 25 kilometer diameter radio or diameter antenna or mirror kind of thing, so that virtually these all can put together and work as a single telescope having a diameter of 25 kilometer. So it's an excellent system. It has given so many excellent discoveries and papers and research outputs. India is one of the dominant countries in radio astronomy research at present in India, at present in the world, and this telescope system is operated by National Center for Radio Astrophysics. So this is just a glimpse to show you that yes, we are also presently in the fantastic top league of astronomy and space research in the world. And as I was telling, to understand, to look into the sky in depth, in proper scientific way, we need telescopes like this. We need observatories, scientific big observatories with excellent telescope and back-end instrument facilities through which we can study the deep space in a meaningful way. So such telescopes are known as professional telescopes. The places where these telescopes are placed are like this. These are known as astronomical observatories. So all these observatories you see, these are some of the greatest observatories in the world, and they are all in remote places of the world. And the last one is going to come. It is a future, it's an artistic impression. So it is going to become the world's largest telescope, the 30-meter telescope system. So in India also, we have observatories. We have wonderful places, wonderful observatories in different aspects, in infrared, in optical, as I have already shown, radio, gamma ray, all types of observatories, whatever is possible from ground, we have in India. So some of the great places for doing astronomy in India are these. I am just giving a very small glimpse of these places. If any one of you really want to study an astronomy professionally and become an astronomer in future, you can take admission into some of these, one of these places. This is not a complete list. You see, these are some of the greatest astronomy research institutes or research institutes where astronomy is done in India. So you see Indian Institute of Astrophysics in Bangalore, IUCA, Inter-University Center for Astronomy and Astrophysics. This is in Pune. ARIES, Aryabhatta Research Institute of Observational Sciences at Nainital, Uttarakhand. We have SN Bose National Center for Basic Sciences at Calcutta, Salt Lake. IIST, Indian Institute of Space Science and Technology at Trivandrum. We have, I was talking about NCRA, National Center for Radio Astrophysics, again at Pune. IISC, Indian Institute of Science, one of the greatest science research institutes of India. This is also in Bangalore. And if we talk about this, there are so many major research institutes. These are all basically central institutes under DST or under some proper central body, central government organizations. And out of all astronomy institutes or all such major research institutes, if I talk, if you want to know that which are the absolutely dedicatedly astronomy research institutes, then these four are only four research institutes we have in India: IIA, IUCA, ARIES and NCRA. These four are absolutely dedicated for astronomy research. In other places, you will also find astronomy and different other aspects of other subjects of science also. For you all, for my friends, I will just try to go to this particular internet website to show you that yes, if you want to know what are the different science research institutes where we can study astronomy, the most premier science research institutes of India where we can study high level astronomy research. You go to this particular website, jest.org.in. Joint entrance screening test is one of the either NET or JEST or GATE. These three are the entrance exams. These are very tough, and these are three are the entrance exams if you want to come to these particular institutes for your master's degree or for your PhD degree. So go to this home page of JEST and come to this participating institutes. Just click here and you see all the 33 institutes who take candidates through JEST program, through JEST exam. You can go, you can click any of these institutes and you can also see what are the topics of research which is going on in every institute. So likewise, you can go to any of these institute, click here, go to their website and gradually search and see where they are located, what type of research they do, what are the types of facilities they have, what are their observatory science, what kind of work they do, everything, every details you can just click anywhere, any of this institute. So JEST has at present 33 institutes dedicated for science research in India. And out of these 33, you will find quite a lot of these institutes cover astronomy research. It is your work. You are nobody who has come here is a child. You all have come because you are interested today in Sunday to learn something about astronomy rather than watching IPL. So that's why it is your work to go back to your room, and if you want to search, you go and do this searching and find out and start preparing if you are seriously interested. So yes, since I am from IIA, just some little bit glimpse about what IIA does. IIA is Indian Institute of Astrophysics. Definitely, it is the leading optical astronomy research institute in India and most probably in Asia also. So we are having a network of laboratories and observatories specifically focused on optical astronomy. For optical astronomy, if you want to do state of the art world class research, you can be a part of IIA. We have our observatories. So the optical astronomy observatory is located at Kavalur, from where I am giving the talk today. I am situated at Kavalur. This is the place, the Vainuvappu Observatory, Kavalur. We have our own solar observatory at Kundai Canal. And near Bangalore, we have our radio observatory in a place called Gauri Bidanur. And definitely all of you, I believe, have heard this name, Hanle, Ladakh, the Indian Astronomical Observatory. Again, one of the finest places in the earth to see the sky. And we have our optical cum gamma ray observatory at that place also in Ladakh, which is known as Indian Astronomical Observatory. To share some pictures with you, this is the place where I am situated now. And if you want to know about this place little bit more, you can go to this article. You just you can copy it and just put it in your online. You will get this article. So this Vainuvappu Observatory is known as the telescope town of India. It is situated in a very small, complete hilly area, Nilgiri Hills, a complete forested hilly place known as Kavalur, which is in Tamil Nadu, near to Vellore. So this is around 200 kilometers away from Bangalore and around 250 kilometers away from Chennai. So this is a place with serene beauty, and for my work purpose, I am stationed here. I am talking to you people staying from a place nearby to this place, nearby to this, somewhere this. The guest house is here. So you can read about this. And yes, this is one of the largest telescopes, optical telescopes, which we have in our observatory. This is the famous historical Vainuvappu telescope. The telescope diameter, the diameter of the mirror is 93 inches. And if you see the structure, just see the whole structure to hold the telescope and its back-end instruments and electronics, and see people standing near it. So you can understand what a major mega structure this is. So with the help of these type of professional telescopes and observatory facilities, we can actually study the space in a meaningful scientific way. And yes, apart from this observatory telescopes, we also have, apart from 93-inch, we have this historical telescope going very front of this 40-inch diameter telescope. This is one of the most historical optical telescope in India. So you see people are standing, when people are standing nearby, you can understand how big it is. It's a very huge system. Only the 40-inch mirror, which is somewhere here, is 500 kg weight. And this is the telescope which is presently serving more than 50 years. Presently, lovingly, we have named it Carl Zeiss Telescope, CZT. And this was the telescope by which some major discoveries were made. For example, Uranus, the rings of Uranus were confirmed by this telescope, by the then director J.C. Bhattacharya and team. Even the first atmosphere of a satellite in solar system was discovered by this telescope. Ganymede, the largest satellite of Jupiter, Ganymede's atmosphere was discovered in 1977 by the help of this telescope. So likewise, I would request any one of you from your school, from your college, any institute, any organization, if you wish to visit this observatory, presently it is open for public. Anyone who wishes to visit this observatory, you can mail us and you can definitely plan a visit to this place, and we will be happy to show you the facilities which we have here. So going to more remote places, yes, as I was telling, we have so definitely Kavalur is a beautiful place to observe the sky. Since it is near to southern hemisphere, the equator, we can observe southern hemisphere and also northern hemisphere stars. But if you properly want to look very deeply into the northern hemisphere sky, from a very remote, wonderful place. That is this Hanle, the Ladakh region. Go to this Ladakh region, you will see this wonderful Himalayas. And ultimately, when you reach, this is the Leh airport. The Leh is the capital of Ladakh. You see the place, almost the Leh airport itself is barren. It's a remote place, very high altitude, extremely cold, less oxygen, but a paradise for astronomers. And from Leh, if you start going towards China border, you will gradually come to these places where nothing is there except these type of mountains full of minerals and wonderful sky. Gradually you go move as early as long as possible, around 250 kilometers away from the Leh city, you come to a place known as this Hanle. And this Hanle is a place very near to China border and wonderful sky. And this is where we have set up, IIA has set up their Indian Astronomical Observatory, which is presently having both optical facilities like Himalayan Chandra telescope, 50 centimeter telescopes. We also have certain instruments for understanding the Cherenkov radiation system. We also have telescope, the world's highest gamma ray observatory at the same place. It is regarded as the paradise for astronomers in India. So this can continue. So I started talking about people who first started watching the sky in primitive day without understanding anything. Think about this 2000 or few thousand years of journey, talking about our own country's progress from where we have come to where. And presently, India in astronomy is having their own particular astronomy satellite, multi-wavelength space observatory. You all know the name AstroSat, which is having 5 particular instruments, or easily speaking, telescopes. So to look at the sky, to look at particular types of objects. So this is AstroSat. Little bit you can learn from internet also. And there are so many other projects, there are so many other missions, there are so many other ideas which are coming up within the next few decades, within the next 8 to 10 years. So if any one of you want to actually read how I can become an astronomer, being an Indian, what are the institutes, what are the facilities, where I can study, what are the eligibility criteria, everything you can get from this particular book, because everything I cannot go within this 1 hour or 40 minutes. That's why I have written this book. This might be a self-advertising kind of slide, but well, please forgive me. I have to show this slide. So if any one of you want to understand, want to know, want to remember how I can become an astronomer, this book is the first guidebook in India to give the guidance to students and teachers and parents how one can study astronomy in every aspect from Indian perspective. You can have a copy of this. Whatever I have told, much more than that, is in details written in this book, including how to prepare for astronomy Olympiads. Now, let me come to the other sector. See, when I was talking, being an astronomer, we people have this. You see, if I am an astronomer, I will first talk about astronomy. If I am a sports player, I will first talk about the sports which I play. So naturally, this happens. So being an astronomer, I have spoken a little bit about astronomy progress, and I feel I have given a glimpse from where to where we have come, from Indian perspective and definitely from world perspective also we can understand. Now, apart from astronomy, for becoming big or great in astronomy research, we also cannot neglect space science. What is space science? Space science or space technology is the development of the instruments or rockets or fuel systems, spacecrafts through which, or the instruments through which we can do astronomy. We can observe the stars, we can study them. So why we need space science? I think I need not have to repeat this slide. Basically, presently, not a single person in this world can actually say that I am not using any benefit coming from space science and astronomy. I will come to this point why I am telling this. So yes, need is there. Space science is necessary for different purposes, and for that purpose, the world actually understood that we need to make space science much more bigger. If we go to the history of how space technology developed, we will see the first rockets, the term rockets, the thing which we call as rockets, were invented by the Chinese. So they use simple rockets, the type of rockets, the firecracker kind of rockets which we use during our this Diwali times. Simple gunpowder filled rockets. Around 800 years ago, they used this type of rockets. But that was for firecracker kind of thing, not for any purpose. So first purpose-based rockets were used in the world by this person. I'm proud to say that the first purpose-based rockets were used in the world by an Indian, and that was by Tipu Sultan and his guardian Hyder Ali. They used rockets for fighting against the British. They made these iron tubes filled with bamboo sticks, filled with gunpowders, and they used it for fights in 1792 and 1799. Some of these rockets are still now preserved in the place where Tipu Sultan belonged, in Karnataka. Please come here and see. You will feel proud. But yes, during those days, gradually rockets were started in coming into use for fighting purpose. For a meaningful scientific purpose, development of rocket, we have to go to the history. You will see the father of space travel, the true father of space travel. This person can be regarded as the true father of space travel. And he was a Russian, Konstantin Tsiolkovsky. And this was the person in 1898 who actually derived the proper mathematical principles of rocketry and suggested that we have to use liquid fuel for powering massive rockets. Using his principles, making more corrections and modifications, we had to wait till 1926. Robert Goddard, the first person, American physicist, who built successfully and flew the first liquid fueled rocket of the world. This was his rocket, and that day onwards, the rocket technology, birth of rocket technology took place. We had to wait another 30 years. These histories are little bit known to many of you, that Russia again became the first country, first nation, the first satellite. The first man-made satellite was launched into space, Sputnik 1, on the 1957, and from that day onwards, the space age started. So from that day onwards, we have come a long, long way. Sputnik 1 didn't carry any animal or human beings, but within 4 years, 1961, the first human being who went to space using some rocket was basically Yuri Gagarin. And the space race and the space age fluently started. Ultimately, by the end of 1970s, America, they have sent man to moon also. And people returned from moon without any harm. During that time, what India was doing. So we know that India became independent in 1947. The condition of India was horrible at that time, extremely horrible. We were also not having proper food. And if you go to the history of Indian history or India's independence history, if you learn about it, read about it, you will come to know that in 1951, Government of India issued a notice that all people of India, please skip one meal. Do not eat for 4 times a day. At least one meal you skip. Why? Because the condition of India was horrible. Because India didn't have rice. We had to buy rice from outside by dollars and pounds. So this was the situation of India in 1951. Presently where we are, presently India is the largest rice producer and largest rice exporter in the world. We sell rice to those countries and earn dollars and pounds from where we used to buy rice in 1950s. Why this happened? Because definitely due to the rise and due to that we understood that we have to become a space power. And that journey, starting from zero, basically I will say starting from minus, negative, to become a space leader in the world, to earn respect from every place of the world, is an incredible journey, is a wonderful journey. Just to give a glimpse, come to these days when 1969 people went to moon and came back without any harm. And in 1960s, some visionaries of India, including Vikram Sarabhai, the father of space science in India, including Homi Bhabha, including this great person Abdul Kalam, who was a young boy that time, Meghnad Shaha, Jawaharlal Nehru, these people understood that we need to develop space science for our own country. That time when these people were thinking that we should have a space program, what was present? In early 1960s, they had no office, no proper office from where we can start a space program, no laboratory, and even no proper funding was available. India's condition, as I was telling, was not good as we see now. But as I was told, they had a great dream. Some of them, some great visionaries, they had a great dream for India. And in 1963, they were successful in launching a rocket from a small village in Kerala. That village name is Thumba. So these are some of the great people, Sarabhai, Kalam, M.G.K. Menon, some of the father figures of those initial days of space science or ISRO's development. And this particular incident started the Indian space program. Now if you come, today we are one of the leaders in space research, in astronomy research. So if you look into this journey from that day to today, it's a long, incredible journey. And in a very short note, this is how our ISRO was formed. In 1962, a committee was formed in COSPER by Department of Atomic Energy, where NASA helped us. NASA told that, okay, we will give you rockets, sounding rockets, and you see whether you can launch those rockets from Indian soil or not. So for that purpose, Thumba Equatorial Rocket Launching Station was made, and within a year, scientists and engineers, those scientists and engineers having no fund, no office, no proper laboratory, they were able to make a makeshift office with dedication and with belief. They were able to successfully launch one sounding rocket, donated by NASA, successful launch, and in the first attempt it was a success. But they understood, these Sarabhai, Menon, Bhabha, these people understood that, okay, if we cannot go on like this, we will only take rockets from other countries and launch them. We have to make our own rockets. For the development of space science, these are necessary. So within next 4 years, again, without having proper funding, proper office, India was able to make their first own indigenous sounding rocket, which is Rohini 75, and successfully launched. And 15th August 1969, the same year when America was able to send man to moon and come back without harming, that same year ISRO was officially born. You might ask me, okay, why within these 7 years the rocket launching and all these things, from where it was going on? Where was the office? So it was a small village, as I have showed you. It is a small fishing village. Till now it is a small fishing village, Thumba, in coastal Kerala. And from this place, this village was the birth of ISRO. And you see there is no road. During 1960s, no road, no transport, no office, no laboratory, no funding proper. So where was the office of ISRO? First office of ISRO where these big people worked. And amazingly, you see there is a church here. This church is known as St. Mary Magdalene's Church. This church bishop gave his praying room, donated his praying room, praying hall to ISRO, to those scientists. When this went to this bishop, told about that what we are trying to do for our India, for our country, bishop agreed, and bishop held a meeting with the village people. All of them agreed and donated this church room for making a makeshift office for ISRO. So our journey to space, basically India's journey to space, started from basically zero. Maybe I will call as negative. We had no office. Our church room was first office of ISRO, presently, if you do visit this Thumba village, this church has become ISRO's official space museum, the first space science museum of India. It's an excellent place. Please visit there. You will be thrilled. I can guarantee that. So this is how our space program started. Now, okay, office is done. A makeshift office now we have. What about road? There was no road. How will you make a rocket? How will you transport your rocket items, big items? This is how rocket parts were transported by bicycles, by hand lifting, and by bullock carts. For so many years in the initial days, for more than a decade, this is how rocket parts were transported to that office like this. Just think about the dedication, just think about the pain these great giants have gone through. Nothing, no success can be achieved in any field by shortcut. My young friends, please remember this word which I say today. You know who is this person? This person was Vikram Sarabhai, and this person was young Abdul Kalam. Think about the pain and think about the dedication they have shown. Means transporting rocket parts in bicycles, by hand, by bullock carts. And this was not only one day. This was the makeshift office where you see this Sarabhai, young Kalam, they were working. And as I was telling, this was not a simple sight or one day activity. Again, this is Kalam. Yes, you see this continued. You see, as I was telling, a whole satellite being designed, made. The parts of the satellite were transported like these, and then from the office to the launching place, this satellite was transported by bullock carts. And during those days, our 1960s, 1970s, if you would have gone to this Thumba village, it was a natural sight, it was a very easy sight. So our Apple satellite system, even in 1981, was transported in bullock carts. And if you would have visited Thumba during those days, this was a very natural sight that a flock of bullock carts will be always traveling in the roads of Thumba village, carrying rockets and rocket parts. For some scientists who are dreaming that we have to become powerful in rocket science. We have to make our nation extremely powerful in space science and astronomy. So this is how basically India's space journey started, from basically zero or negative. Where we are now, it started its journey very simply from zero, and it was 1975 when we were able to make our own satellite and launch it successfully, and we named it Aryabhatta, honoring that great medieval astronomer Aryabhatta. So this is a statue which you will see if you visit Ayuka anytime. Now presently, what we have, you see as 1980s onwards, the first indigenous rocket system which was designed by India, by Indians, was this synchronous launch vehicle. This was SLV, and the project director for SLV project was APJ Abdul Kalam. So from like this, we have made our own rockets, the power, the lifting capacity, the scientific accuracy, precision, everything has increased. And presently we have our own geosynchronous satellite launch vehicle with which we can launch satellites even to Mars and beyond. So this is a long, again I am telling, it's a long journey. I am just giving a small glimpse within few minutes. 1 minute, I am having a phone. Hello? হ্যাঁ বলছি একটা টকে আছি গো, আমি একটু পরে তোমায় ফোন করছি। হ্যাঁ। So, and we have our own launching stations at present. We did not have to depend on others. We have our own launching stations from we can launch our own rockets on satellites. So this is Satish Dhawan Space Center at Sriharikota in Andhra Pradesh. Like this, we also have some more. So this journey, I am just giving a glimpse. It's a long journey of 60-70 years from zero, how we made our started our journey in space science, and now we are leading. We are one of the best space science leaders in the world. Presently, some of the greatest satellite systems which is indigenously designed by India, launched successfully by India and operative. You see this INSAT series, Indian National Satellite System, This is one of the largest and most powerful domestic communication satellite system in the whole Asia Pacific region. It's a series of satellites which covers the whole communication system over India and outside India also. So I can talk from a remote jungle in Nilgiris from you with you people, and there is no interruption going on in communication because we are not dependent on others. We have our own satellite systems which is helping in communication. As I was telling, not a single person in the world and obviously in India can today say that I am not using the benefit from astronomy and space science. So now you can gradually think, anybody who is using a mobile phone or camera or laptop or communication, any type of communication mode, digital communication, is indebted to astronomy and space science and Indian science, Indian space science. Likewise, so these are some of the salient features. I will not go to the details. You see, we have our satellites designed from first from Rohini, and presently we have our own satellites in different aspects, different subjects for different purposes. We have our mapping satellites, we have our education satellites, communication satellites, we have our monitoring. Means monitoring means for the security purpose, defense purpose, we have satellites. So you see this Cartosat satellite. We have our own Cartosat satellite which can map the groundwater in India, the groundwater levels. And this helps us. This helps us to understand which is our agriculturable land, what type of crops can grow in which region of India. So as I was saying, now gradually I feel you people can understand that we all are dependent on space science. We all should be dependent on space science, and we all should feel proud to be Indians, because how we started and where we have come, gradually we are getting a glimpse of that. We have our own disaster management, weather forecasting, remote sensing satellite systems, and this RISAT. Why I am showing this particular RISAT satellite system is because it's another important feature is it is used for tracking the famous line of control in Pakistan. It's in Kashmir region. So it's a survey satellite for defense purpose. Okay. So for surveillance of Pakistan occupied Kashmir, this line of control, we use our own satellite. We need not have to depend on somebody else. So these are some very small glimpses what we have now. And if you look into India, we have ISRO centers almost in every place of India, every state of India, covering the whole India, including Port Blair and all these Andaman Islands. We have more than 20 ISRO centers, which helps to give us the support in different space related activities, space science related activities, communication, remote sensing, is geographical weather forecasting, and every aspect. Sending education to remote places, food management, every aspect. So this has happened. Think about the first pictures which I have shown, when in Kerala we had to transfer our rocket parts by bullock carts, even by hand, even by bicycles. Just around even 40 years, 45 years ago, we were doing that same thing. And within 45 years, from that day, how we have transformed. We have ISRO centers covering the whole network of India, and we have our own confidence that we can protect our country if any kind of hazard comes. So, if in details, if you want to read from that small fishing village to red planet to Mars, how India has reached, this book I will definitely recommend. It's almost more than 700-page book. Please read this book. It's a wonderful historical book telling about India's space journey and how ISRO's programs or ISRO's satellites and these ISRO's programs have helped almost every type of Indians, every type of people in India. That is written in details in this particular book. These are all available from online. You can buy it and go through these books. I will just come to some of the modern, wonderful, successful missions which India has made. You all know about, apart from doing own purpose-built technology or purpose-built missions, India is now focusing on exploring space using their capacity. So Chandrayaan 1, I was in young stage, I was during my BTech times when Chandrayaan 1 was first lifted successfully, and we were able to discover water molecules in moon using Chandrayaan's one particular instrument known as Moon Impact Probe. Gradually, we have come a long way. I till now remember that date, 24th September 2014, when India became the first nation to send a spacecraft to Mars within a first attempt. It's extremely difficult. It's very, very difficult to send a mission to Mars and successfully. You can read about Mars missions, history of Mars missions. You will see that extreme number of failures have come for all the countries except India. So yes, we have learned from the failures of others, and this was made. So this was Mangalyaan mission. We presently have Chandrayaan 3 mission, which is successful, which has landed on moon, and various other missions are coming up. And definitely, apart from research institutes, apart from these topmost universities or ISRO, presently India has is going to open the space industry for private sectors also, so that if any private company, any new organization want to support this ISRO's missions, the space science development missions of India, they can also come forward. So there are so many companies, so many new initiatives have come forward within the past 4 5 years, and which is a good sign. We are progressing rapidly, at least in the field of space science, defense, and all these areas which are important. You can definitely be a part of this space science and astronomy if you want. Seriously, you can become a part of this. You can become an astronomer, you can become a space engineer, you can become a space scientist, and definitely be a part of this particular technique. I will just end within another 5 minutes just to tell you why we should study astronomy. These are few reasons why we should study astronomy. I would like to highlight one particular reason or two particular reasons. See, I am telling that space provides us the most extreme laboratory, and also somehow astronomy helps us to make our life comfortable. Definitely, you have gradually understood that yes, by space technology, by the knowledge which we get through astronomy and then through space science, our life becomes comfortable. I have mobile phone, I have easy communication because of astronomy. But let me give a glimpse. See, extreme laboratory means what? You see sun. We know that sun is a burning ball of gas, extremely dangerous. And if we can actually see those solar flares which are coming up, means which are basically flames of fire which are coming up. So if you take sun's one solar flare and make a bigger picture, how that solar flare looks like is like this. You put our earth in front of a solar flare, one flame of fire which comes out from sun, and our earth will look like this. But there is nothing you should think that our sun is, yes, definitely is powerful, extremely dangerous star, but it is not the largest or the most dangerous star in the world. The same thing, same kind of picture we can make if we put our sun in front of the largest stars of the sky. You see this particular star, NML Cygni. In front of this star, if we put our sun, it will only look like a dot, a 1 pixel. 700 crore suns will fit inside one star like this. So this is to give an example why I am telling that the most extreme natural laboratory to study you will get in space. You cannot get this type of laboratory anywhere in the world. And as I was telling you, see, astronomy and space science research makes our lives comfortable. How can anyone tell me what happened, what general people got by sending Neil Armstrong to moon? America has spent billions of dollars. What we got, what general people got by this mission, by Apollo missions. It is a long history again. I am just showing some small snippets. How many of you know that the water purification system, AquaGuard and all these things which you are using in your home now, this water purification system was designed for Apollo mission astronauts? How many of you know the deep fridge system was discovered for for these people, not for us. How many of you know proper home insulation came, modern home insulation was discovered for Apollo missions? You see, programmable pacemaker, gas analysis, memory foam, even kidney dialysis machine, proper improved kidney dialysis machine, so many things came, were invented because Apollo mission was held. So this is just to give a idea how some abstract subject like astronomy, how understanding whether we can send a person to moon or not, whether a star is evolving or not, what is the life cycle of a star, these are all abstract subject, abstract knowledge. How abstract knowledge of astronomy, quantum physics, mathematics helps everybody in future. We have to study astronomy, that is why. And yes, this is another book which I would like to highlight. If you want to look at the sky, it is an abstract book. How abstract science helps humanity to progress. This is one book about that. What is this book about? If you ever try to look into the sky and think about one question, that is there any one particular object in the sky by exploring, by studying which humanity's progress has been made the most in every aspect, in science, technology, philosophy, history, geography, just by exploring one celestial object. Has that happened? Yes, that one celestial object is Mars. It has always acted like a showstopper. So this book explores that humanity's incredible achievement or incredible true story, that for 2000 years, just by exploring one object that is Mars, how humanity has progressed in every aspect. Now you can go through these things, and if you like, you can go through this real detective story of 2000 years. You will come to know about it. I will end my talk. I have already taken more than 1 hour. I will end my talk here. Thanks to all of you for listening. Thanks to all of you for your patience. And if anyone is having any question, any doubt, if you want to ask something, you are free.
Sir, I have a
Yes, yes.
sir,
Okay, hello. Hello.
Yeah, hello, hello. Yeah, yeah.
Yes, sir. Thank you so much, sir, for this wonderful and enriching speech. Now, I would like to request all the participants, whoever has any kind of questions, please raise their hands to clear off their doubt.
फोकस के साथ देख रहा था सर, तो वो स्टार अपना पोजीशन थोड़ा चेंज करता है, लाइक समटाइम्स लेफ्ट राइट अप डाउन.
That is because of your handling that camera in your hand.
नो सर, नॉट कैमरा सर, विजिबल आइज सर, आइज से मैं देख रहा था. वो स्टार है, वो थोड़ा दब दब कर रहा था, लाइक वो
दब दब तो
कांस्टेंट.
करेगा. हाँ, दब दब तो कोई भी maximum star will do. So
बट सर,
all the stars will do. All bright stars will do.
तो सर
In which region you are watching? In which region of the sky? What time?
इन विच रीजन ऑफ द स्काई सर?
Yes. Which
Sir,
region? East, west, north, south?
साउथ डायरेक्शन सर.
South direction. Okay. And which time you were watching?
सर अभी सर 1 घंटे पहले सर 7.
Okay. So it was a very bright star, right?
सर नॉट वेरी ब्राइट बट या इट वाज विजिबल थ्रू माय आईज ओनली.
Okay. Okay. So that might be a star. That might not be a star also.
ओह
Yeah.
सर, on
If
last
that object is moving, then it is a satellite. Yeah. And if that object is not moving, then it is the reflection effect.
sir, in the
If it is
last
a very bright star, then it is Canopus, the second brightest star in the sky. In the south, it is. If it is a very bright star.
okay. In the last also I asked a similar question. You said that you saw Jupiter planet.
Mhm.
But sir, today it's not like it can be a star or it might not
Yes,
be a
yes,
star.
definitely. Yeah, because you are watching in the south. In the southern direction, if you see, that might not be Jupiter. Yeah, but if you are looking in overhead, means your zenith position, Jupiter is presently in the overhead direction.
Oh.
Yeah. South direction, the only bright, very bright star is, definitely there are bright stars, but I'm not sure which particular object you are looking. But the southernmost brightest star is Canopus, naked eye
बट
star.
क्यों होता है सर? लाइक वो स्टार लाइक धप धप करने लगता है, ब्लिंकिंग होने लगता है.
Definitely hoga, stars will twinkle because of the light being passing through the, you see, we say, right, stars twinkle because light being passing through the atmosphere and it will be refracted, so it will happen.
I see. Thank you, sir.
Thank you, thank you. Yeah.
Okay, next Pranjal Sharma. You speak.
Uh,
Yeah, Prakash.
so, sir, my question is more like academically related.
Yes, yes.
So, if I'm preparing for CSI or NET for any of the colleges for astrophysics, like the ARIES or IIA,
Yes,
so
yes.
what subject should I be choosing? Because there are, I guess, five different kind of subjects. It is
So if
mathematics,
you,
then there is
if you
math
want
and
to go to astrophysics, then you have to choose net physics or gate physics. And JEST is basically physics. JEST exam is based on physics. Yeah, so
okay.
if you want to go to physics, yeah, means
Yes, sir.
astrophysics, then you have to cross through net or gate physics and then come
Okay.
to the interview. Yeah, so that is the thing. You
So,
have to
sir,
qualify
CSI has work for this.
net. Yeah, you have to qualify through net physics. This is the thing.
Sorry, sir, I didn't get your.
Yeah, you have to qualify through net physics. Yeah, then only you can be applicable for the interview. And for IIA, IUCA, all these places, maximum of the premier institutes will call for interviews if you have more than 95 percentile marks in NET or
Okay.
GATE or JEST. Yeah, this is the thing.
Okay.
But
So, sir, there any reservations or anything related?
no, I don't think so. There is nothing called reservation in research.
Okay. Okay.
Yeah, you have to
Thank you,
go
sir.
through the, as you know that what Newton told to a king, if there is no royal road to mathematics, I tell the same thing in a different way. There is no royal road to knowledge. You have to pass through that pain.
Okay, sir.
Yeah, thank you, Pranjal. Yeah.
Okay, anyone else has any more questions? Pranjal Sharma, your hand is still raised.
Alok is there. Alok, yeah, you can ask your question.
Yeah, hello.
I am saying that everybody please kindly join the WhatsApp group for the participation certificate. You will get there only, and a Google form link you will get. So fill up in the WhatsApp group. See in call there in chat there is the WhatsApp group link is there. Please everybody join.
Okay, I was also going to see the same thing. The link to the WhatsApp group of our Talisha is given in the comment section. Please go through it and join the group in order to get the e-certificates, electronic certificates online. Okay. And I would like to request everyone to switch on their camera for a short amount of time to go to get the group picture together. Please don't leave the meeting now. This is a humble request to all the participants. Switch on your camera one by one and we will take a screenshot of all of you.
Okay, done. Thank you. Thank you, everyone.
Okay. Thank you, everyone. Nice to meet you all. Thanks.
Thank you, sir, once again.
Thank you, sir.
Okay. Yeah, all of you please join the WhatsApp group. Okay, this was the end of the meeting. Now you all can leave the meeting one by one.
Those who want to get the e-certificate, join the first. Join first through the link. We are already put our link in the chat. Please visit and join. For future updates, join this group. Thank you, everyone.